Hello everyone. 大家早上好. Today I'm going to go over some of the progress that we've seen in the blockchain space over the last year, including some of the technical progress that we've seen, including some of what we have learned about the technical progress that is still left to go, and what kinds of things people are building with blockchains now that people have not been building 1 year ago, or that people have been thinking about 1 year ago, and what all of this means for the development of the blockchain space as a whole. So, to start off, where are we now? So I personally would split up the kind of history of the blockchain space into 3 major periods. So maybe in the first 5 years, and it was primarily focused on Bitcoin and on using cryptocurrency for payment. And so for the first maybe 2 or 3 years, Bitcoin was the only blockchain that existed. And even before that, using cryptocurrency as a store of value and a medium of exchange was what most people were thinking about. From 2014 to 2017, people's focus and interest became broader. So people became interested in using blockchain-based applications for things other than payments. And this included often other kinds of financial applications. This would include decentralized peer-to-peer financial contracts, insurance, crowdfunding, DAOs, all sorts of more complex financial applications than simple payments. And it also included applications that have nothing to do with finance at all. So using blockchains to create decentralized DNS systems, to maintain registries of various kinds of personal data. And people also became interested in smart contracts, general purpose blockchains. So this was the idea that Ethereum was built around, that we could have a blockchain which, instead of being optimized around one particular application, could be designed to handle everything. And a lot of interest from this large institutional groups. Now, where are we going to go from now is what I see as the third era, which is where we finally get to some kind of large-scale mainstream use. So, first of all, where are we now? And one thing that we already have a lot of is hype. And hype including hype from the general public and institutional hype as well. So when Vladimir Putin knows what blockchains are, and what Paris Hilton is actively promoting at ICO on Twitter, we know that we have hit the top. So, and there really are a lot of things that people are trying to build, right? So these have all existed for over 1 year, and we've seen a lot of different projects. A lot of them are even being done inside of governments. And in the last year particularly, it's the kind of institutional interest and progress has sped up even more quickly. Right? So we've been seeing the United Nations looking to use blockchains to improve the efficiency of tracking cash payments. We've been seeing multiple central bank issued digital currency trials. We've been seeing traditional insurance companies looking at using Ethereum-based flight insurance. And there's a lot of different applications being created by various organizations, large and small, US, Europe, and Asia, and progress is speeding up even more quickly. And we even have Estonia wanting to issue their own coin. So we already have a large number of proof of concepts. We have a large number of experiments. We have a large amount of institutional hype, and we have a large amount of institutional interest. But we do not have yet are working large-scale applications. So why? So my own opinion is that the main obstacles right now are not lack of interest, but really are technical obstacles. And so maybe 2 years ago or 4 years ago, there was still a lot to be gained
by kind of spreading awareness of the technology and helping, just getting the word out so that a lot more people hear about it and become interested. Right now, a lot of people already are interested, and the limits that we're hitting are actually limits arising from the technology itself. Now, the one place where you can feel these limits more clearly is in the space of existing public blockchains. So if you look at Bitcoin, Bitcoin has this self-imposed limit where every block in the Bitcoin blockchain that comes every 10 minutes has a block size of 1 megabyte. And if you look at the chart on the left, this is the size of Bitcoin blocks, the number of transactions that are put into each Bitcoin block on average. And as you can tell, over the last 6 months, the chart has kind of hit a ceiling, and that ceiling is Bitcoin's 1 megabyte limit. So this is, now, I mean, you could say it's a self-imposed political limit rather than a kind of a limit of the technology itself, but the fact remains that these blockchains are filling up very quickly, and they are very soon actually going to hit technical limits of the way that the technology actually works. Right? So if you look at Ethereum, its usage is also increasing very quickly, and its transaction usage has actually recently surpassed Bitcoin. So Bitcoin is doing about 200,000 transactions every day, and Ethereum is doing about 350,000, the peak being at 490,000. And its blockchain is close to full already. So just technologically, with this current approach, there isn't really that much more space left to go. With maybe if you optimize, we can increase by a factor of 2, a factor of 4, a factor of 10, but ultimately there is a substantial technical limit here. Now, we've been talking about scalability solutions for a long time, and I mean, there have been kind of several major categories here. So one of them is to try to improve public blockchains themselves, including doing things like sharding for scalability, technologies based on state channels, the Lightning Network. I mean, Plasma has been announced a couple of months ago, and some people are also looking to consortium chains as a scalability solution. Now, these are all things that people have been talking about for years, and that have been under research and under development for years. Though I would say in the past year particularly, there has been a lot of progress in actually implementing a lot of these technologies. So Raiden is announced a developer preview about 1 week ago. And the Lightning Network on Bitcoin is making progress. Plasma was announced, and there are teams already starting to build implementations. And sharding, there is already a proof of concept implementation in progress. Consortium chains, for Ethereum specifically, a company in Taiwan called ME recently released something called Istanbul, which is a consortium, a version of Ethereum that has a consortium chain-friendly consensus algorithm built into it. And JP Morgan has been working on Quorum, and as I understand now, these two groups are collaborating with each other. And there are many other systems that are being built and continuously being improved as well. So all of these different directions are things that people are actively working on, and at the same time, I think over the last 6 months especially, it has become very obvious that scalability is one of these large problems that we do need to be thinking about. Privacy. So privacy continues to be a significant issue in the cryptocurrency space, although it's one that I would say is probably affecting institutional applications more than consumer applications, just because in practice, institutional users tend to care about privacy at an earlier stage and more directly. But it's, and a lot of these groups are, often come to me and they say, look, we want to do something on the blockchain. We would want to, use the Ethereum blockchain to keep track of payments, to keep track of information about people's identities, to keep track of things on the supply chain. But we have this problem that if all of the transactions are public and all of the information is public, then it just doesn't work with the privacy requirements that they already have. Now, there are two kinds of privacy solutions that I generally talk about. One of them being low-tech privacy solutions and the other being high-tech. So low-tech privacy solutions are things like simply encrypting data before it goes on the blockchain. And Quorum, the Ethereum consortium chain implementation, already actually does this. Right? There's also many projects which try to store encrypted data in a system other than the blockchain, and then push the hash of the data onto the blockchain. There are even state channels do at least partially preserve privacy. So there are solutions that do not require that much kind of advanced math or advanced cryptography to implement. They are fairly simple, and for many applications, they give fairly good results. There are also high-tech solutions to privacy. So before I came to Shanghai yesterday, I was in Israel for 1 week, and I was attending this cryptography workshop at the Technion, where some of the people presenting were some of the leading mathematicians and cryptographers who are advancing this field in technology that's called, or in cryptography called zero-knowledge proofs. And people have heard of zero-knowledge proofs a lot, and they have a lot of hype. And this is for a very good reason, because zero-knowledge proofs are very, very powerful. So what zero-knowledge proofs let you do is they let you prove that you have some piece of information, and that piece of information satisfies some properties, without revealing anything else about what that information is. Now, on a blockchain, you might interpret that as you can have a blockchain where every transaction is encrypted so that only a few people can see the details of any one transaction, but where these zero-knowledge proofs are used to allow anyone to, so any node in the network, to verify that a transaction is correct without revealing any details about what the transaction does. So this is something that's very interesting for the blockchain space specifically, because blockchains solve some kinds of information security problems. Blockchains solve the problems of making sure that data is valid, making sure that everyone agrees on what piece of data got committed to the blockchain at what time. If there are multiple pieces of data that are incompatible with each other, then which one of those pieces of data arrived first? So they solve problems like timestamping and guaranteeing correct execution of processes. But they do so at the cost of some privacy. Zero-knowledge proofs solve the problem of privacy. So this is why these two technologies make such a good combination. So Zcash is a cryptocurrency that was created specifically around using zero-knowledge proofs, and in this case, a type of zero-knowledge proof called a snark, specifically to increase privacy of cryptocurrency transactions. So Ethereum in Metropolis, so Metropolis is the next major update to Ethereum that should appear next month, the main theme of this next update is to add a large number of different forms of advanced cryptography into the Ethereum virtual machine so that smart contracts can use them to build various kinds of privacy-preserving applications. And snarks are one of the types of cryptography that will become possible in Metropolis. Now, there are also other things that will become possible as well. So, for example, Metropolis will include support for RSA, which will allow you to more easily build applications that interact with certain kinds of applications that have been built in the traditional world. It will include support for things for ring signatures. It will include support for threshold signatures, and these are often used in things like cryptographic anonymous voting protocols, in various kinds of privacy-preserving and privacy-improving applications. Now, the presentation that these cryptographers made in Israel was actually about Starks. And Starks are a kind of the next generation of zero-knowledge proofs. Right? So the benefit of Starks is, first of all, they can be used to prove almost anything about about some piece of private data, and they can also be used. They also have the benefit that the number of cryptographic assumptions that they rely on is very low. Right? They do not rely on any fancy elliptic curves. They do not rely on a trusted setup. All they rely on is hash algorithms and math. And so, this is the Starks as a construction are kind of very powerful and very robust. And this is part of why a lot of people are very excited about them. So this technology, and it is all technology that we have been talking about for several years, but now the main difference between this conference 1 year ago and now is that, first of all, Zcash already exists. Metropolis and Ethereum will exist in probably 1 month, and the technology is continuing to improve rapidly almost every week. Security. So security continues to be very important, and these are problems that become more and more apparent the closer we get to trying to actually implement blockchain applications for the masses. If in a blockchain, a user interacts with an application by signing messages with their private key. And the private key is just a number. It is a piece of data that has to be stored somewhere. Maybe it's stored on a user's phone. What happens if you lose your phone? What happens if your phone gets hacked into? So these are user account security problems. There are also smart contract security problems. How do we know that some smart contract does not have a bug? How do we know that some smart contract does not have any malicious errors that were introduced into it deliberately? These kinds of problems are more difficult to solve, but there are groups that are working on solving them. And over the last year, there have been very significant upgrades to the security of programming languages. So programming languages on Ethereum that compile down to the Ethereum virtual machine. There have been substantial improvements to Solidity, and there's a new language called Viper, which also tries to take a more kind of simplicity-oriented approach to security. And there's work being done on formal verification. So there has been, it's not even close to being perfect, but there has been progress. And finally, there is the security of the protocol itself, which is something that we are also getting continuously better and better at. So another important challenge in the blockchain space is governance. So this year, we've seen 4 of the top 10 cryptocurrencies are now some kind of fork. Last year, we had Ethereum and Ethereum Classic. This year, we have Bitcoin and Bitcoin Cash. So, this is something that may well continue to happen. And this idea of if in a public blockchain, groups disagree on the direction that the protocol should take, what actually happens, is a challenge that's still kind of being worked out over time. Right? And it is going to be it is a very interesting challenge, and there aren't very easy answers. And sometimes the only answer is to split a currency in half, so that both sides can have a currency and a blockchain that works the way that they want. But this is one of the things that is going to likely continue to happen, and probably needs to kind of get a better understanding of, and so that the public can have kind of good expectations about how reliable each individual blockchain is, what kinds of events are likely to happen, how often do things like this happen, and so forth. So there are, now part of the reason why this kind of governance is necessary is that there are a lot of inherent trade-offs in blockchain design, right? So sometimes you have to choose between protocol features and safety. So do you make a protocol that's more powerful, or do you try to make a protocol which is simpler in order to improve its safety properties? Do you prefer to reduce the cost of running a node to make the blockchain more decentralized, or do you want to try to make the blockchain more accessible by reducing the cost of transactions? And One of the goals of blockchains is so that many people can verify it. But another goal of blockchains is that it's an open platform so that many people can use it. And there is a clear trade-off here. Scalability or decentralization. What security model? Proof of work, proof of stake? Is it a consortium chain? Efficiency, privacy? So the fact that there are these different things that you have to choose between, I think shows that there can't be one blockchain to rule them all. And I think realistically, we're going to see different kinds of blockchains, and we're going to see various different kinds of systems. And some of these systems are going to be basically just centralized databases with hashes. Some of these systems will be public chains. Some of these public chains will have different properties. Some of them will try to be as scalable as possible. Some of them will be simple payment systems. Some of them will try to focus on smart contracts, some on non-financial applications. And we are going to see every kind of intermediate solution in between a centralized database and a public chain. Like we've already, in general, as a civilization, we've learned that centralized systems are useful in many cases, and we're increasingly learning that decentralized systems have their value, a lot of value in many different situations. And chances are there will be cases where everything in between these two extremes makes sense. And I think that we will see more and more platforms being built at almost every point along the spectrum. Thank you.
Thank you, Vitalik.